Only about 5 centimeters in diameter, a car's thermostat sits between the engine and the radiator. Until the engine warms up, it blocks the flow of coolant to the radiator. When the engine reaches about 95 degrees Celsius, the thermostat opens, letting coolant flow through the radiator and into the engine to prevent overheating. The key component inside the thermostat is wax. When the engine heats up, the wax melts and the thermostat opens, triggering the cooling system. The wax melts quickly because it contains powdered copper, graphite, and/or aluminum. As the wax transforms from solid to liquid, it expands. The pressure pushes a pin that opens the valve that enables the flow of coolant to the engine. After heating and mixing in the powders, workers pour the wax into slab-shaped molds. It takes about a half hour to cool and solidify. Then they extract the slabs and grind them up. They feed the granulated wax to a pill-making machine, the kind pharmaceutical factories use. It compresses the granules into cylindrical pellets. Meanwhile, workers feed a copper strip into a machine called a high-speed transfer press. Its successive stations shape the copper cup that'll house the wax pellet. The first station stamps out a circle. The others progressively stretch and form the circle into a cup. The cups go into an automated assembly machine, which drops a pellet into each one. A pin then bores a hole down the center of each wax pellet. The machine inserts a rubber sleeve into the pellet hole and caps the sleeve with a brass cover. Then it crimps the cup over the cover, forming a seal that's leak-resistant. Now the machine inserts the stainless steel pin that opens and closes the coolant flow valve. The pin goes right into the rubber sleeve in the center of the wax pellet. How do all these parts work together? The melting wax expands within the cup, squeezing the rubber sleeve. That forces the pin upward, opening the coolant valve. Now they heat the parts to the temperature at which engine cooling should kick in. A calibration machine squeezes the cup until the pin rises enough to open the coolant valve. The components now enter a machine which connects that valve. The valve is made up of 2 stainless steel pieces. The machine loads one on top of the other over the thin end of the cup, then pushes the valve over the end of the cup, attaching it to the wide end. On the left is before the valve installation, and here's after. Meanwhile, a press forms the top part of the thermostat, called the flange. It's made of stainless steel coated with a lubricant. As with the cup, a series of dies progressively forms the flange. Now for the final assembly. First, the thermostat's stainless steel frame. Next, a stainless steel spring. Its job is to close the valve when the engine cools. Now the assembled components go inside the spring. The flange goes on top. A tool called an orbital riveter flattens a tab on either side of the flange. This holds the frame onto the flange. The assembly machine now crimps 2 little tabs against the pin, keeping it from falling out of the rubber sleeve. And with that, the thermostat is finished. This demonstration shows how the melting wax pushes the pin upward. And when the engine cools, the opposite happens. So that even though you might boil over in heavy traffic, your engine doesn't have to.